Welcome back, folks. Time to learn how to turn those big and small numbers into something manageable by converting them to a different unit system. And to do that, we're going to build what are called conversion factors. Now, these factors are going to look like fractions. They're going to have something on the top and something on the bottom. And our goal is to create conversion factors that do two things for us. Number one, we want them to get us into the unit we're aiming for. Number two, we want them not to change how big the measurement itself was. That's the plan. Let's see how we do it. As we said, the goal here is to change one thing while not changing another. We want to make sure the unit changes to what we're after, but that the actual value of the measurement does not. So if we think briefly about the first part, how do I change one thing? Well, units are going to act just like algebraic variables. When I say 5 centimeters, I might as well just be saying 5x, where x equals 1 centimeter, right? And so essentially I'm just taking whatever this is and I'm multiplying it by something. And so the question I would ask you first is, how do we cancel out variables in algebra? How do you get rid of one? Take a moment, think that over, come back to the video when you're ready. Okay, I hope what you came up with is you divide it out. Right, so if I want to get rid of this x, I might do something to the equation that allows me to divide by an x, and then it disappears. Similarly, if I want to attach a new variable, what I'm generally doing is multiplying it in. So if I had, for instance, a 5 and I wanted it to be 5y, the way I do that isn't by adding or subtracting or dividing, it's specifically by multiplying. So when we build a conversion factor, our goal is going to be to put the unit you're trying to get to on the top and the unit you're trying to get rid of on the bottom. That's the general plan of attack. Now, the question of not changing the other thing, okay? Question for you. What is the only thing you can multiply by? Because you'll notice everything we're doing here is multiplication and division. What's the one thing you can multiply by that doesn't change the value of a number? Pause the video or just scream it at the screen. I hope that what you came up with is the number 1. That's it. And as such, I tend to call conversion factors fancy ones. They're very useful versions of 1, but they have to eventually equal 1, or they're not a good conversion factor because they won't assure that the value of the measurement's the same as it was before. So to do that, what we need is the value on the top of the conversion factor and the value on the bottom of the conversion factor to be equal to each other. So one thing we want to get in the habit of is when we know that we've built a conversion factor to get from meters to millimeters, for example, or from inches to yards, we want to take a moment to finish that conversion factor by putting in the number that makes it work, that makes the top and the bottom equal to each other. So for example, I'll go ahead and do one of these guys here because this you would have to look for either on an info sheet if you were taking an exam or in the inner cover of your book. I believe it's on the back cover. There's a list of conversions that go between English units like this one. English units only in this guy right here. I don't expect you to know these off the top of your head, but if you look them up, this one is 36 inches equals 1 yard. And a good rule of thumb here is that as you're writing these numbers in, and you're writing in this fraction bar, many of my most successful students have made a point of saying that as they do it. They say 1 yard is equal to, or is the same as, 36 inches. And that way they remember that's the relationship they're going for. And if they say it out loud and it sounds wrong, they very frequently catch it. What I'd like you to try to do is pause the video and fill in these 4. You can leave that one for last. You should be able to find that on the back cover as well of your textbook. But definitely try out these 4 using the metric prefixes that we talked about on the last video. Pause. When you come back, we'll try them together. Okay, for some of these, there are 2 pretty equally reasonable ways you can do it. One thing is to look at this prefix, milli, centi, nano, and say to yourself, well, that prefix means something, and so I'm going to put the thing it means with meters. In other words, a millimeter is 10 to the minus 3 meters, or a centiliter is 10 to the minus 2 liters, or a nanogram is 10 to the minus 9 grams. Notice there's no inherent logic about whether the power of 10 ends up on top or bottom. It's all about making the two things equal. And as long as you can confidently say one of these is 10 to the minus 3 of that, you've got a good conversion factor. Now, a very common way of dealing with these is to instead finish this conversion factor by asking yourself, how many of the small unit do I need to make the big unit? Some of us really don't like having negative powers of 10 on the bottom of our conversion factors. So another way you could do this is to say, well, if a millimeter is 1,000th of a meter, that means that 1,000 millimeters is the same thing as a meter. Sorry about that, I keep hitting a cord for my dock cam. Similarly, if a centiliter is 1/100th, 10 to the minus 2 liters, that means it would take 100 of them to make a liter. And similarly here, if a nanogram is 1/1000th of a gram, it will take, to make 1 gram, 10 to the 9th nanograms, or 1 with 9 zeros after it, nanograms. Now, you might ask yourself when you see this, and you're seeing two different ways to do it, well, what if I mix them up? How am I going to know that I did it correctly? And to help you with that, we're going to learn my golden rule of conversion factors. And it's this, especially when you're dealing with metric, because you should have a sense of what those prefixes mean. Make sure the big number goes with the small unit. And make sure the small number goes with the big unit. Okay? You can see that borne out right here. In each of these cases, millimeter, centiliter, nanogram. Those are your smaller units. So in these cases, I've taken the big number and I've put it with the small unit, with the millimeter, with the centiliter, with the nanogram. Over here, where we're using small numbers, notice the small number, 10 to the minus 3, 10 to the minus 2, 10 to the minus 9, is going with the big unit, the meter, the liter, the gram, okay? All of that in preparation for you trying this one out right here. Take a moment and see if what you wrote for that conversion factor follows Dr. H's golden rule. And if it does not, fix it. I'll give you a moment, pause the video. And here we go. What you should have here is 1,000 meters equals 1 kilometer. Now let's think about that particular result for a moment, because it wouldn't surprise me if a few of you did this. It's a very common mistake that I see, because people say, oh, kilo means 1,000, and they wind up together like this. Notice how both of our methods should hopefully short circuit that, though, so that you don't put this on future assignments. Number one, notice that in each of these cases, if I'm using the power of 10, the 10 to the third right here, that power of 10 doesn't go with the one that has a prefix, right? 10 to the minus 3 went with meters because that's what milli meant. 10 to the minus 2 went with liters because that is what centi meant. Same thing here. 10 to the third, or 1,000, ought to go with meters because that's what kilo means. You need to have one on one side of the bar, one on the other. Again, though, the other thing we can do is think about it in terms of big unit and small unit. Notice that in this case, the smaller unit is the meter. The bigger unit is the kilometer. So I don't want to have the 1,000 with the kilometer, because then I'm doubling up on big. I need the 1,000 with the smaller unit. In fact, if you want to think about this just in terms of stuff you can see, the easiest way that I find to tell them apart is that if I look at the one that says 1,000 kilometers over 1 meter, I ask myself, are those the same thing? And a way I can check it is to say, show me with your hands, what does 1 meter look like? About like this, right? If I then say, what does 1,000 kilometers look like? Show me with your hands. You are going to sprain something because it's from here to Nebraska. It's a large, large distance. Those aren't the same. Finishing things up on here, the last one we've got is milliliters to fluid ounces. This is an English to metric conversion. I also don't expect you to know these off the top of your head. Hopefully you looked it up in the back of your book and found that it's 29.6 milliliters to the fluid ounce, more or less. That is not an exact number like the ones we talked about last week, but all the rest of these most assuredly are. The powers of 10, whether they're listed in scientific notation or like this, as well as at 36. Those are counted. Those would not factor into your sig fig calculations. Now what we're going to do is set up some of the conversions we were aiming for on the last video and try to employ all of this logic. You'll notice that for each of these we're trying to get rid of meters, so I've already pre-installed the meter as the unit on the bottom of every one of these. But now what we want to do is set up the unit on top. Now we said before that megameters or gigameters would be a good idea for the distance from Earth to the moon. We agreed that kilometers would be pretty good for this one, so we can finish this right away because we already worked it out on the last one. We said this one, which was roughly 10 to the minus 2 meters, would work out great if we used centimeters. And subsequently, this one that's going to 10 to the minus 5, we would have a choice between millimeters versus micrometers. Let's go ahead and use micro in this case, just to get used to seeing that little mu, that Greek M that indicates millionth. Okay, your job is to pause the video and fill in these conversion factors with the right number in the right place. Feel free to refer to your metric prefixes while you do it. Okay, what you should have here is for megameter, 1 megameter is 10 to the 6th meters. That's what that ought to look like, pretty much regardless of how you went about it, because really either whether you're saying big number goes with small unit and vice versa, or if you're saying put the power of 10 on the opposite side from the prefix that means the same thing, either way you get the same result. Same thing that happens with kilometers, kilo meaning 1,000. Now, centi means 1,000th, so you could have done this one of two ways. Some of you might have this, or 0.01 in that top spot. Some of you might also instead have the version that is 100 centimeters equals 1 meter. Those are both perfectly fine. Either way, you're in business. Mathematically, they're the same thing. Lastly, here at the bottom, if we're doing micrometers, you could do this one of two ways. I'm going to flip which one's which in this case, just so that we're seeing all of it. One thing you could do is say 10 to the minus 6th meters is a micrometer, or you could say that I need 1,000,000 micrometers, 10 to the 6th, to make a meter. Either of those work out great. Use whichever one you're comfortable with. Once that's all said and done, now it's just a matter of putting this into your calculator. If we take this and divide by 1,000,000, notice the meters are going to cancel out, and I'm going to wind up here with 384 megameters. If you decided to do this with giga would have been 10 to the 9th. We would have wound up with 0.384 gigameters. Taking a look at this one here, as I convert into kilometers, 49,000 divided by 1,000, the meters are going to go away. We punch that into the calculator, and it's 49 kilometers. Notice these zeros out here are at the end of a big number with no decimal. So unless told otherwise, we're going to assume those are not sig figs and ignore them. Moving on to this one, 0.03 times, oh dear. So, I don't know if any of you noticed or caught it. I made a goof right here, and it's known to happen. I've said beforehand that asking somebody to speak at a blackboard generally costs them about 20 points of IQ. Turns out the same thing's true of a whiteboard or a document camera. My mistake. I hope you caught that this should have been 10 to the minus 2 on the bottom and 1 up here. Notice that we want the small number with the bigger unit. Big number with the smaller unit. So just goes to show, any of us can do this by accident, but when you sit and think critically about it for a moment, you'll usually catch it if it was wrong. In this case, 0.03 divided by 10 to the minus 2 is going to give us 3 centimeters. Same thing would happen if we took 0.03 and multiplied by 100. Lastly, this divided by 10 to the minus 6, or this times 1,000,000. Both of those should give us 70 micrometers as the result of this. Notice in this case, we are going to add a 0 out here, but because I don't have a decimal point, that 0 is still not a sig fig. Anytime you do one of these things, your last significant digit should continue to be your last significant digit in the new result. So keep an eye on that as you go. Down here at the bottom, I have a variety of these for you to try out for your own practice at home. What I will do in a moment is actually put the answers to them on the screen so that you can check your work. Here they come. Okay, there are our results, and I want to point a few things out to you as you're going along, just in case you got very slightly different results from what I came up with. Notice that the 0 here is not a sig fig, so it doesn't get copied over to this place. But that 0, coming with a decimal point in the number, is not a placeholder. That's actually showing me something about the uncertainty. That is a 0 at the end with a decimal in the number. So there you go. That 0 comes along for the ride. Last but not least, this may look a little different from what you came up with. You might have come up with 1198 or 1200 if you tried to round it to this place. But notice that if you end with that number right there, to me, that looks like it has 2 sig figs. But we know that should have 3. 2.54 centimeters to an inch is exact, so I need to show this with 3 digits. I need to show that that's a sig fig, but that's not. The only way to accomplish that is by showing it in scientific notation, so I can make that 0 count. So now that we've got a sense of how to do a basic conversion for something that you can simply find in the back of a textbook or in your own knowledge of metric prefixes, now we're going to look at some other types of ratios that could get used in problems like this and will on Wednesday during our Zoom session. Click on the next video to see that.